Good afternoon, everybody. I'm Kwabena Peprah, and I'm privileged this afternoon to do a presentation on the proactive approach towards electrical motor maintenance and troubleshooting. So the mode of my presentation will be in this form. I'll briefly talk about myself. I'll introduce the problem and the reason for that topic. We will move on to selection of motors, transportation, storage, and installation. Then finally, we talk about commissioning, test and inspection, and maintenance and conclusion. All this will be geared towards electrical motor maintenance. So selection will be based on the maintenance requirement during the selection. In terms of my educational background, I had my first degree at University of Mines and Technology in the year 2009, after which I followed up with my career and profession. Um, I had the privilege to do my graduate trainee at Gold Ashanti Obuasi Mine, where I became a graduate trainee and rose through the ranks to become electrical superintendent from 2011 to 2021. Currently, I am the unit manager, electrical and instrumentation at Asante Gold Bibiani Limited since 2021 to date. In terms of my career experience, I've taken a lot of projects which involves motors ranging from fractional horsepower to 5 megawatts motor, very big motors. And in terms of projects, I was part of the new CIA, new flotation construction and commissioning, where a lot of motors were installed, commissioned, and tested. And during the Obuasi mine redevelopment project and the Bibiani mine redevelopment project, I was the lead electrical engineer in charge of the processing plant. And a lot of motors were commissioned and tested. In terms of professional affiliation, I'm a member of Ghana Institution of Engineers and also our own WAIMM, West African Institute of Mining, Metallurgy and Petroleum. And now, why this topic? Most equipment in the mine, right from the crushing circuit through to the conveyors, to the milling, to the agitators, to the valves, compressors, and what have you, all use electric motors. Basically, there's no equipment in the mine which is not driven by electric motor. Therefore, there is the need to holistically look at a way it can be maintained proactively to avoid downtimes which have ripple effect on the profit margin, workers' bonus, and what have you. So the proactive approach we are going to look at is right from the ordering of the motor through to the transportation, installation, commissioning, and the maintenance and troubleshooting. Which people are the target group? Mining industries are the target group, and every industry which predominantly uses electric motors, engineering, mining, and metallurgical professionals are supposed to be equipped with the strategies to maintain motor proactively so that they will have the availability and reliability of their plant and their mining session. And what am I going to cover in this presentation? Like I said earlier, I will look at the selection of the motors with maintenance in perspective. I will look at the transportation, storage, installation, commissioning test, and maintenance and troubleshooting. On the screen is an exploded view of an electrical motor. Basically, there are some parts which are often neglected, like the drain, this drain point, like the fan cover and the fan and the cooling fins. They are often neglected as not being important, but the health life of the motor predominantly depends on this very part, which plays critical role in their operation, which we will look at in the course of the presentation. So when motors are being selected for any project or any application, there are some basic ratings we look at that, like the power, the voltage, the speed, the frequency, frame size, and the mounting side. That is B3 or B5, foot mounted or flange mounted, and the ingress protection rating. On the screen is a typical nameplate data of a motor. Um, there's something I want us to note. On this nameplate, we have the installation class, and we also have the um, temperature rise. The insulation class is F, and the temperature rise is seen as being 80 degrees Celsius. We will look at this one also in the course of our presentation. You can also see the type of grease, the bearing numbers, and the running hours after which greasing must be done. So with maintenance in perspective, when selecting motors, you look at the environment you are going to install your motor. Is it a very dusty environment? Will the motor be exposed to chemicals? So based on that, you select your IP rating using the ingress protection chart. For instance, for typically mining industries, an IP66 is okay. For IP66, you see is full protection against dust and other similar particles. In terms of the solids and in terms of the water, is protection against jets of water at a rate of 100 liters per minute at 100 kPa pressure at a distance of 3 meters for 15 minutes. So based on your application, you choose your right IP rating. Else you go and install a motor with a wrong IP rating and you risk the chance of losing the motor in no time. And in terms of the installation also, the installation environment is very critical. For instance, we can see on the screen a motor with a shaft slinger and a motor with a rain hood and a motor with eye bolts, and we have an explosive proof motor. So if the motor is going to be mounted vertically, you have to specify that you need a motor with a shaft slinger. But the general purpose motors, they come without a shaft slinger. So without a shaft slinger, with continuous exposure to rain, to slurry, to dust, they will permeate through the seals of the motor and the bearings will be lost in no time. I remember during my early days in my career, we had a flotation plant where general purpose motor was used for the vertically mounted motors. You install a bearing and within 3 months, you have to replace. And basically, after a motor has undergone overhauling, we don't subject it to the test to ensure that the right IP rating is in place. So it's better you procure a motor with a shaft slinger to protect it against the ingress of chemicals, slurry, and rain on the shaft because it is vertically mounted. And for those which are vertically mounted with the cowling or the fan facing to the atmosphere, it's expedient we get a motor with a rain hood so that rainwater and particles coming from the atmosphere do not get direct contact to the shaft, and by so doing cause the bearing to fail. So based on application, the right motor is selected, and also an explosive proof motor based on the environment, whether it's a hazardous area. So based on the hazardous area classification of the area, you know you are buying an explosive proof motor for a zone 1 area or a zone 2 area or a zone 0 area. So you look at your environmental factors and you choose your right application, whether you need a lot of eye bolts around the motor so that it can be mounted correctly. The general purpose motors do not have eye bolts to all the sides for the vertically mounting. So in such application, you need the right motor so that you are not faced with any challenge in the course of the installation. Also in the environment, the same environmental factors during motor installation. You look at the insulation class and the insulation class of the motor. Per the NEMA standard, we have the 4 motor insulation class, the class A, B, F, and H, and all of them have their rate of temperature tolerance as seen over here. For an insulation class A motor, it can have a rise in temperature up to 60 degrees. So for an ambient temperature of 40 degrees, the motor can rise up to 60 degrees and has a hotspot of 5 degrees Celsius, after which the motor will fail. Same applies to other insulation class, like say insulation class F. With an ambient temperature of 40, it can rise up to 105, and it has a tolerance of only 10 degrees Celsius. So at 155 degrees Celsius, the motor will fail. So based on your application, if you are going to mount the motor at a hot environment, you specify it and you procure the right motor. Let me go back and show you something on the nameplate data. On the nameplate data of this one, the insulation class is F, which means the motor can go up to 155 degrees Celsius. But it is stated on the nameplate that the temperature rise is 80 degrees Celsius. So though it has an insulation class of F, but it has a temperature rise of 80 degrees Celsius. So if you install it at an ambient temperature of 40 degrees, you do not expect the motor to fail at 155. It will fail when the temperature rise up to 80 degrees. So let's say 120. But advantage is that at a hotter ambient temperature, like an ambient temperature of 70, you can still use this motor, because at a temperature rise of 80, you'll be around 150, which is near to the breakdown temperature, which is 155. So insulation class is very, very important when selecting our motor for our application. And the technical data, every motor and its application is being used for. So when procuring motor, it's prudent that we ask for the technical data of that motor for us to do our right analysis in the selection of the motor. On the screen is the technical data, which shows the lock rotor or breakaway torque of the motor, the pull-out torque, the breakdown torque, and the rated torque. According to NEMA design, we have the 5 design types, the design type A, B, C, D, and E. So based on your application, the motor behave differently according to their torque. Let's look at a design class D. For a design class D, it has a very high starting torque, but as the motor approaches its full load speed, the torque reduces. So if you have a load which have dynamic torque, which torque increases with time, like with a crusher application, and you select a design class D, though it can start it all right, but in the course of running, you'll be having a lot of trips. The motor will trip. Maybe you need a 400 kilowatts motor or a 280 kilowatts motor. But with a design class D, it will not be able to accommodate the torque. But let's look at a design class C. For a design C type, The motor will have a torque about 200, starting torque about 200% of the rated torque. But as the motor approaches its full load speed, the torque is higher. The torque is higher. Look at the screen for the design type C. You see the torque is higher as the motor even approaches its full load speed. So in such application, if you know you'll be facing dynamic torque, which will require the motor to have enough torque to do the work, you specify the torque or you inform the manufacturer the application you are going to use. Normal general purpose motors are design type B. So if you do not specify and choose the correct motor, you will have a lot of maintenance issues, a lot of trips. So your starting frequencies will increase. And when the starting frequencies increase, chances are that the motors will overheat. And when the motors overheat, it will get insulation failure and the motor fail. This chart shows typical examples of design type and their application. Let's look at the design type C, for instance. You can see that it's used for conveyors, for crushers, for steering motors, agitators, reciprocating pumps, compressors, and etc. So based on the application, you must select your design type. Else, manufacturers will manufacture your motor according to design types B, and you will have a lot of issues in your operation. One very important issue which is often neglected, especially by maintenance team, is motor transportation, storage, and installation. I remember in one installation I was involved, a motor had a defective bearing. It was sent to a workshop outside the mine for replacement, but during transportation, the shaft was not locked. So the motor was bouncing on the track. The motor came, everybody was happy that the motor has arrived, it was installed. And the day it was tested, we found that the bearing was defective. So a root cause analysis was done, and we found out that during transportation, the shaft was not locked. So look at the downtime it caused. After the installation, it has to be decommissioned again, retransported to the site, new bearing had to be procured and reinstalled. So it's prudent we look at transportations when we are doing motor application. We look at the transportation, we're doing the motor application, make sure the shafts are locked so that we do not experience any hazards in the course of the installation. And excessive dust exposure. When transporting, we must make sure the motor is thoroughly covered to prevent dust exposure, and cable entry point, especially for motors which are in use. When cables are removed, cable entry point had to be plugged before they are transported for overhauling, and when returning from overhauling, the plug has to be in place to prevent dust exposure into the windings and also into the other parts of the motor. And during storage, especially for new motors which are critical spares, we must ensure that the space heaters are connected, and there should be a routine checklist on the motors to ascertain that the motor is in good shape. The windings are heated regularly. So monthly basis, you have your checklist. You go and check whether the heaters are working. You check your insulation resistance, and you record it and you keep it in your maintenance software you use in your area. And for motors which has to be stored for a long time, especially for one rotor motor which has moved, to prevent any chemical reaction between the brushes and the slip ring. So during storage, we must ensure we remove our brushes, and the springs are also removed to prevent them loosening their tension when they are needed. Also, the shaft must be properly protected during storage with denso tape or any other protection chemical which protects the shaft from corrosion. And when new motors are procured, which will be spare motors or to be installed data, it is expedient that we do verification of the nameplate data. We do not wait till the day of installation before we are found wanting and we are forced to use the motor for an application that is not designed for. And when you are forced to use a wrong motor for the right application, chances are that you have a lot of maintenance issues. So verification is very, very important, and correct handling during installation, especially if the motor is a general purpose motor and you are going to mount it vertically without the eye bolt, you might put stress on the bearings in the course of your installation, and this will even affect the bearings during the installation, and the bearing life is drastically reduced. And the shaft slinger, which I mentioned, and the rain hood for vertically mounted motors are very important. So during your installation, you put the right things at the right place and you avoid other issues afterwards. Now, let's come to the commissioning and the maintenance of the motor. We are looking at the proactive approach with the issues of the failure of motors in mind. If you know that a lot of motors fail, about 51% of motors fail through because of bearing failure, you put critical attention on maintenance on the bearings. And if you know that the stator winding accounts for 16%, you know where to put it. So based on the statistics we have, 51% of motors fail through bearings. But most of the time, bearings are normally not taken very care of by electrical maintenance professional. Their attention is most of the time on the windings, but windings account for only 16% of failures recorded, which means that bearings failure needs to be critically looked at in terms of electrical motor maintenance. So bearing failure, which issues causes the bearing to fail? Excessive greasing or wrong greasing has been found to contribute to a lot of motor bearing failure. When we were looking at the exploded view of the motors, I pointed to the drain plug of a motor. Motors normally have a drain plug so that as you pump in new grease, the spent grease passes through the old plug out of the motor. But in the case that the plug is blocked by hardened grease, you pump a new grease into the motor and the old grease is also there. So you overgrease the motor, and when the motor is overgreased, it causes overheating, and overheating eventually leads to the failure of the motor bearing. So we must ensure during motor maintenance that the drain plug of the motor bearings are clean and clear, devoid of any blockages, so that when new grease is pumped into the bearing, the spent grease will have a clear path to move out of the motor for the motor to be equipped with new grease for another running hours designed for it. And also when greasing, you have to be very cautious, because if you over pressurize the bearings, chances are that the bearing seals the bearing lip seals will give way, and when the bearings give way, you loses your motor because the bearings will not be contained. So just be cautious. Technicians are to be cautious when greasing motors and observe the tensioning. When they observe any pressure, they have to stop. Wrong lubricant has been found to contribute a lot to motor bearing failure. Check on the motor technical data and see the grease which was used. Whenever two grease are mixed, it causes overheating. So if it's an EP2 grease, you get your EP2 grease. Don't mix EP2 with EP3 grease. Chances are that you cause a motor failure, and this has been observed to contribute a lot to motor bearing failure, which contribute 51% of motor failures. Insufficient lubrication has been accounted for. When the greasing time is due, technicians must have a chart, not just have 3 months interval greasing or 4 months interval greasing. Greasing should be based on running hours of the motor. So if per the OEM, after 2,000 running hours, you are supposed to grease, ensure you have systems in place that observe the running hours, and after which you are notified by your system that is due for greasing. Normal lubricant intervals are done based on 70 degrees Celsius. And for shielded bearings which are shielded, the ZZ or RR bearings, they are lubricated for the life of the bearing. So for a temperature of 70 degrees Celsius. So if the temperature, operation temperature goes above 70 degrees Celsius in the course of the operation, the greasing frequency must be reviewed. So for instance, the table below shows that for operating at 60 degrees Celsius, the greasing frequency reduction is by a factor of 1.59. But if it increases to maybe 80 degrees Celsius, a factor of 0.63, and so on and so forth. So based on the temperature the motor bearing operates, we use your chart to have your greasing frequency so that you will not under grease or over grease the bearings, cause the bearings to heat up and cause failure. Misalignment has been found to cause a lot of motor bearing failure. The rule of thumb is that after every 2,000 running hours, ensure you do your alignment check and you proceed on. You do not wait till you observe any misalignment. Every 3 months, you do your alignment. In so doing, you help your motor bearings to have peace and run successfully, and you avoid unnecessary breakdown. Don't wait till you have issue. Have a strategy to check your alignment, and your bearings will last, and your motors will also last. Also, shaft overload, especially motors which are bear driven. Uh, a lot of time pressure is put on the motor at the drive end. So because of the pressure, the bearings do not operate freely and they are lost prematurely. So if you know your application will be predominantly bear-driven application, you inform your manufacturer, and the drive end bearing of the motors, cylindrical roller bearing is recommended. And if you use it for that application, you extend the life of the motor and the motor is okay. Vibrations are found to cause a lot of motor bearing failure. So we do not leave vibrations checks to only the mechanics or the condition monitoring technicians. As professionals, we ensure that there are no vibrations, because where there are vibrations, we are reducing the lifespan of the motor bearing. Now let's look at the 16% of the failures which are caused by the motor winding. Whenever a motor is overheated, a 10% reduction in operating. Whenever a motor is operate under 10% of its temperature, you double its lifespan. So the lesser the temperature, the longer the lifespan of the motor. So we must ensure that our cooling system of fan cover, the fan cover guide to cool the motor through the cooling fans. So we must ensure that the cooling systems of our motors are working effectively, because the cooler the motor, the longer the lifespan of the motor. And excessive start causes major overheating. So you select your motor, your correct motor. If you need a design type C, you select it so that you avoid frequent trips. And frequent trips, when avoided, you avoid frequent startup, and your motor will not be overheated, and you have your motor running for a longer time. Overloading of motors. We must ensure we put in the right overload application so that motors can operate. And then it has about a breathing space of about 20%, so that when there is even an overload, the motor will be able to accommodate it. Now let's look at typical examples of motor thermal cap. The red red curve shows the motor thermal curve when the motor is hot. What do I mean by motor hot? Motor is hot when the motor is running and is in operation. That motor is called hot. And a cold motor is a motor which has stopped, and the cooling time of the motor for it to cool up to the ambient temperature has elapsed. Maybe the cooling time is 20 minutes. If the motor has stopped and the cooling time of 20 minutes has elapsed, that's a cold motor. So for a cold motor at a rated current of about 600% of the rated current, from the chart, it can stand up to 20 seconds, up to close to 20 seconds. But for a hot motor, it can stand up to close to maybe 10 seconds. It will fail. So it is prudent that we know how at a lower current. You see that the thermal capacity use is smaller. But when motor is being operated at a full load current, a higher thermal capacity is being utilized. So the lesser the current, the more the motor enjoys freely, and you increase the lifespan of the motor. Let's look at a typical example. This motor was started, and it instantly drew up to 600 percent of the rated current, and the motor was stopped. So because it did not reach up to 5 seconds. After 5 seconds, it was supposed to reach its full thermal capacity, but after 4 seconds, it was stopped. So this motor has already reached 80% of its thermal capacity. So if this same motor you start it, you do not expect it to also go up to 600%, and it will wait for 5 seconds before it will trip. For this one, if you start it and it draws up to even 300%, within a short time, for normal situation, for 300%, it was supposed to wait up to 30 seconds before it reached its thermal capacity. But because it was initially started up to 600%, it has only 20% of its thermal capacity available. So you start it, and you use maybe local resistance starter, and it draws about 300% of the motor rated current. It will have only 6 seconds for which the motor has to reduce in its current, or else the motor is going to fail. So if you do not have the correct motor protection relay. The motor will be started and the next start again, it has no cool down and you have about 80% left. It will allow the motor to go up to 600% and you lose your motor. But with the right motor protection relay and with the right settings, it will understand that previously it reached 600% of its capacity. 80% of its thermal capacity has been used. I have only 20% available. Also for 20%, based on my algorithm, when my current reaches 300%, though I'm supposed to wait for 30 seconds before I fail, but because of the previous experience, I have only 6 seconds available. Then the motor thermal relay will trip the motor. So it's prudent we use motor thermal relays, motor protection relays, not the for our critical motors, for our mills, our crashes, our um, critical applications. You use your motor protection relays, and based on these values you get from the manufacturer, the motor hot and cold thermal curve, the full load rated current, the lock rotor store time when cold, the motor running and stop cooling time, the service factor, and the thermal rise and the insulation class. These values are inserted into the motor protection relay. So the motor is able to understand its operation, where it had reached, when to take action to protect the motor from failure. These values are very critical and should be requested from the manufacturers when procuring motors, so that during 16%, 16% of the motor failure, I was still at the 16% of the motor failure through the insulation breakdown. So the starting frequency must always be checked. Motors comes with the number of starts per hour. So you check and you insert it into your motor protection relay. For the smaller motors, we must ensure that we also check the number of starts. If you start a motor and it was overloaded and it tripped, you must wait for it to cool down before you restart again. So put in the right parameters and it will restrict operators from using the motors. Over voltage, under voltage causes rise in current and insulation breakdown. So you put in correct settings, 10% and 10% for under voltage, so that when there's a rise or a dip in voltage, motor is protected. The circuit is cut off to protect it from failure. Harmonics has been found to cause heating and vibration of motors. So especially the VSD, which has a far distance between the motor and the VSD, we must ensure that inductors are installed to protect the motor from harmonics, which will cause heating and vibration. Vibration can cause failure, and we must ensure proper earthing of our application so that all these issues can be resolved. Next slide. Next slide. So how do you determine that your motor is overheating? Normally, when motors are overheating, you will see dark spots on the winding. So when you are replacing your motor bearings, or you are doing any replacement on your motor, must take advantage to watch the windings. Dark spots indicate the signs that your motor is undergoing overheating, so that the corrective action is put in place. Next slide. Next slide. Yes, motor operating temperature is very critical. Motors are normally designed for an ambient temperature of 40 degrees Celsius. So if you have an ambient temperature of 40 degrees Celsius and you are going to operate it at an ambient temperature of say 45, there is a derating factor, and it's also designed for an altitude of 1,000 meters. So based on your application with a higher ambient temperature, you derate your motor to fit your application so that the motor will not fail prematurely. Next slide. Next slide, please. Next slide, please. External condition has been a lot of contribution factor of motor failure, like plug, vent, damaged cooling fins. All these issues, if not resolved, if you have a broken fan, the fan will not be cooling the motor enough, like I shown on the motor thermal capacity. The fan is supposed to operate constantly to cool down the motor. And in a humid environment, if the motor is operated in a humid environment, the anti-condensation heaters must always be working. Whenever the motor stops, it has to be designed in such a way that immediately it stops, the heaters comes in to take over so that condensation will not take place for the bearings to fail. And contaminations contribute to a lot of motor failure. Must ensure that motors are protected. If they need canopies to be protected, we ensure they are protected from all the external environmental effects for the motor to last longer. Next slide. In terms of commissioning, proper documentation is very, very important. Motor, as you install motor, the nameplate data is likely to fail. So you get your proper documentation and you put it on your work management system, the motor nameplate data, so that in case of future analysis, you know the nameplate data and you know what to do. The size of cable which was used must be documented and put in your work management system. And in case of one rotor motors, the wear rate of the carbon brushes must be determined. So if it wears at this rate, you know when to change your carbon brushes. If you wait for your carbon brushes to wear out thoroughly, you end up losing your slip rings. So the bearing, the carbon brushes wear rate has to be measured and aligned. Alignment results must be kept also in the work management system. After the motor has been installed, the alignment has to be done and the results has to be kept so that for future references, you know what the alignment was. So 3 monthly, you check your alignment, you ensure there is no deviation, and where there are deviation, you correct it and you allow your motors to run in good shape. And no load and full load vibration results must also be taken during commission. You have your no load vibration and your full load vibration. So you know your motor is operating rightly, or the equipment your motor is driving also have an issue. You have your data and you keep it for future analysis. And your protection relay configuration values also has to be kept so that in future troubleshooting, you know that during commissioning, the temperature setting was at this, the cooling time was at this. So what happened? What changes has come into place? So initial protection relay values have to be kept in your work management system so that you are covered and you know where to refer to during troubleshooting. Insulation resistant test results. During motor commissioning, the insulation resistance is tested. This results also shows the strength of the insulation as the motor is being operated. So as you run and you measure it, you can compare it with the initial values to see whether you are losing your insulation or the insulation is intact. The no load and full load current also has to be taken. Motors normally have um, about one third no load current. So you have your no load current and you ensure that my no load current is okay, so that when you run on full load and there are issues, you know how to analyze your fault to identify the root cause of it. Current and voltage imbalance. Voltage imbalance is very dangerous. Even as 1% of voltage imbalance is not acceptable. 1% motor imbalance means you must stop, investigate, and resolve. Current imbalance can be tolerated up to like 10%, but voltage imbalance is no-go area. And the type of coupling and pulley ratio for your application all must be noted down so that in future troubleshooting and references, you know this was the type of coupling being used. This was the pulley ratio. So what has changed? What what caused the pulley ratio to change? Has the pulley ratio caused the motor to draw high current or whatever? So these initial values has to be kept and managed well for future references during troubleshooting. Next slide, please. Let's look at a typical example of motor current imbalance troubleshooting. Let's look at this motor. It has one phase of the current drawing like 15 amps, another phase drawing like 14, another phase drawing like 17. Somebody will just look at this value and say, okay, oh, the difference is not very wide, so the motor is okay. But it's prudent that after running your motor, you do calculation. You must calculate and confirm and convince yourself that the imbalance is within the tolerable level of 10%. For this one, you find the average. The average we got was like 15.3. And you subtract the highest deviation from the average. The highest deviation was 17. So 17 minus 15, we got like 1.7. And we find the ratio to the average. And upon that, we got 11%. But physically looking at this one, you would think that the imbalance is manageable. So it's always prudent that whenever you commission a motor or you are troubleshooting, you take time to calculate the imbalance to ensure that it's within the acceptable range, or else physically looking will deceive you that the imbalance is tolerable. Next slide, please. So how do you correct imbalance? So when you have imbalance, you must ensure whether it's from the grid system or it's from the motor. If it's from the motor, you have to replace the motor. If it's from the grid, you have to correct from the grid. For this one, you have your phase one drawing 112, phase two 126, phase three 116. You move the list of the cable and you swap it to different phase. If you observe that one phase is consistently high, even after swapping the list, then you know that it's coming from the grid, or it's coming from your your whole power reticulation system to ensure that the imbalance is resolved. Maybe there is voltage imbalance which is causing the current imbalance. Next slide, please. Next slide, please. Conclusively, I would say that motor maintenance starts with right selection. You know you are going to mount your motor vertically and you buy a general purpose motor without a shaft slinger. Chances are that the bearing will fail prematurely. So right selection, you know you are going to run your crusher. You go and buy a NEMA B design instead of a NEMA C design. The motor will trip frequently. It will trip frequently, and your chances are that you lose your starters, you lose your breakers, you lose your insulation. Right selection is very important, and proper transportation, storage, and installation. Transportation is very important. When transporting motor, make sure the right things are put in place. The shaft is locked, motor is properly covered. And when installing, make sure you handle the motor properly. Don't put stress on the bearing as the motor starts failing even before you run them. And proper commissioning and documentation and the usage of work management system. Do proper um, commissioning. You document all the issues from commission, the running current, the motor parameters, the type of coupling, the alignment results, the vibration results. You keep it as your reference point. So during troubleshooting or maintenance, you check a bit against your baseline. And proper understanding of motor operation, like the thermal curve. You know your motor has just stripped and you go and you start it again without allowing the motor to cool down. You want to bypass system and allow your motor to work for you. Proper understanding will help you do a condition-based maintenance. You know that, no, let me check my bearings. I understand the windings are failing based on the issues I have. So with this, you increase motor lifespan and you reduce your MTTR, mean time to repair, and you increase your mean time to failure. Next slide. Um, Thank you very much.